All right, today we're going to talk about the metric system. This unit coming up is basically the math that you need to be able to use when you're going through chemistry, so it's the applied math. We'll talk about metrics one day, we'll talk about Sig-figs, which is where to round, and then we'll spend a couple of days converting from one unit to another, which is very important for what we're doing in the future. Again, base units for different things that you need to be able to measure and convert. You need to know the difference between mass and weight. Again, mass is the amount of matter that's in an object, and it doesn't change. It doesn't matter, whether you're here or on the moon. The amount of matter in an object is the same. And weight, again, is the mass of an object times the pull of gravity. So that means weight changes depending upon where you're at. You don't weigh as much on the moon as you do here on Earth. Again, quickly kind of fly through some of these things, just the things you might have to make calculations over. Temperature is, as far as what temperature is, if you walk outside on a really cold day or you touch a hot stove, what the difference is the energy of the molecules. So the faster the molecules are moving, the more kinetic energy they have, the higher their temperature. So again, temperature is the average kinetic energy of an object. Kinetic energy is 1/2 mass times velocity squared. You don't have to make any calculations with that, but I'm just pointing out again, the faster an object is moving, the higher its kinetic energy. Now, the temperature scales, it could be, we use still Fahrenheit here, the rest of the world uses Celsius, and but the metric unit for temperature is actually Kelvin. And so when we do gas laws later in the year, all of our gas laws, we plug in numbers or make equations associated with gas laws, we have to put the temperature in Kelvin, because there is a direct or inverse relationship only when the temperature is in Kelvin. But the Celsius scale is based on the freezing and boiling points of water. 0 Celsius is the freezing point of water, 100 Celsius is the boiling point. And you can quickly convert from Celsius to Kelvin simply by adding 273. So if you want to know again the Kelvin temperature, all you have to do is take the Celsius temperature and add 273 to it. It says normal body temperature is 37 degrees Celsius, or that's 98.4 Fahrenheit. What is that in Kelvin? 37 plus 273, 310 Kelvin. It says the melting point of the metal gallium is 303 Kelvin. Would it melt if you held it in your hand? And so what you would do there is you've got the Kelvin temperature. So get from Kelvin to Celsius, you subtract 273. So Celsius to Kelvin, add 273. From Kelvin to Celsius, subtract 273. So 303 minus 273 is 30. And so yes, if it would melt at 30 degrees, then gallium metal would melt in your hand. Different derived units, again, those are combinations of base units that you might have to calculate. We'll focus on volume and density today. But again, volume of an object, you should know what that is, just the amount of space that's taken up by an object. I will say that volume measurements can be a little bit confusing. This is a standard unit of volume. It's a decimeter cubed, or 1/10 of a meter on each side. And so, but when you talk about the volume of an object, you have regular shaped objects, and then you have irregular shaped objects, or things like water, which typically you wouldn't use decimeter cubed. If we were to take this wood out of the middle of this and fill it up, this is also a liter. So a decimeter cubed is 1 liter. One again used for regular shaped objects, the other used in this case for liquids, like I say, or irregular shaped objects. And so you also need to understand, so this is a decimeter cubed, and a decimeter is 1/10 of a meter. So this is 1/10 of a meter, and these markings across the bottom, these are centimeter markings. So you can see it's got 10 centimeters across the bottom. But if we say how many centimeters cubed are in a decimeter cube, we have to say 10, and 10 depth and 10 high, and so 10 times 10 times 10 is 1,000 cubic centimeters in this. And if we were to take the wood out and fill it up with water, again, this is 1 liter. 1 liter is 1,000 milliliters. So if this is 1,000 milliliters and 1,000 cubic centimeters, that means that a cubic centimeter and a milliliter are the same thing. So that's what I'm pointing out here. So a decimeter cubed and a liter are the same, which also means that a centimeter cubed and a milliliter cubed are and a milliliter are the same as well. To calculate the density of an object, it is mass divided by volume. We would compare everything to the density of water. Think for a second whether or not you know the density of water, or if you knew that already. I've already written it down here for you, but density of water is 1. 1 gram per cubic centimeter or 1 gram per milliliter. That is the density of water. So if you throw something in water and it sinks, it has a density greater than 1. Like gold's density, I think, is 19.6. So it is 19.6 times more dense than water. And if you put something in water that's density less than 1, it'll float. Not only will it float, but you can tell basically its density relative to water based on how much of it is above the surface of the water. You know, this is a piece of wood here. We throw it in the water, and if half of it floated above the surface, then it has a density of 0.5. Half of it will be below the water, half above. Ice has a density, notice, of 0.92. So that means like an iceberg. When they say most of the iceberg is underwater, like 90% of it's underwater. Only about 10% or 8% in this case are above the surface of the water. So again, we'll compare everything, density to water. Density again is mass divided by volume. So you make some density calculations, should be easy to do. So what is the density of a block of marble? That is 853 grams. And it occupies 310 centimeters cubed. Just divide the two, quickly do that, and it is 2.75 grams per cubic centimeter. And so there you go. The next problem there, they get a little more complicated as we move on. It says density is 3.26 grams per centimeter cubed. Now, when you're doing density problems, I would set them up like a proportion, because it's easier to solve. Because what I find is when people have to solve for volume in a density problem, they don't know what to do. Like again, so density is mass over volume, and this is X. Can't tell you how many people over the years will be and I'll be like, what do you do? Multiply, divide, they'll just start guessing on how to solve for it. But let me show you again the easiest way to set these up to solve for X, especially when it's volume or in the denominator. So you'd say this is 3.2 grams over 1 centimeter cubed. It's the same thing. So this and this are the same thing. And it's a ratio between the two. For every centimeter cubed, you had a diamond. If you had a centimeter cubed of diamond, it would weigh 3.26 grams. So they're asking what is the mass. So that's X. And the volume, in this case, is 0.350 centimeters cubed. Now that that's a proportion, you should know what to do with that. You cross multiply. So again, so we have X equals 3.26 times 0.35. And I'll do that real quick. 3.26 times 0.35 and get an answer of 1.14. And 1.14, and that would be an answer there in grams. And let's see, moving on to the next problem. Again, this is, like I said, it gets a little tougher there. So we've got a density of mercury of 13.6 grams per milliliter. Again, those are the same things. That's the way you express density, set it up as a proportion. And it says the mass is 76.2 grams. What is the volume? Cross multiply to solve for X, so it's not a mystery. So you've got 13.6x equals 76.2. And we're going to divide there. 76.2 divided by 13.6 is 5.60. So X is 5.60. And again, that would be in milliliters. So hopefully you got that. That's today's lesson on density problems. You will have a puzzle to work on that. So good luck.